Hello students, in our previous session we had learned nth term of arithmetic progression. We shall continue our session with some of the properties of arithmetic progression. The first property is if a constant quantity is added or subtracted from each term of arithmetic progression, then the resulting terms of the sequence are also in AP with same common difference. To understand this, I have divided as two cases. First case for addition and the second case for subtraction. So case 1, by adding a constant quantity suppose if I consider an arithmetic progression where the first term is a and the common difference is d, the second term will become a plus d, third term will become a plus 2d, fourth term will become a plus 3d, and so on. If a constant quantity k is added, suppose constant quantity k is added, then sequence will be a plus k, a plus d plus k, a plus 2d plus k, and so on. Here the first term will be a plus k. Common difference will be second term minus the first term. The second term is a plus d plus k minus the first term is a plus k. We get the difference as d. If you observe third term minus the second term, a plus 2d plus k minus a plus d plus k, the difference will be d. Since there is the same common difference, this sequence, the new sequence, is also an AP. Since common difference is same, this implies a plus k, a plus d plus k, a plus 2d plus k, so on, is an AP. This is a proof for when a constant quantity is added. Let me consider the second case now. The second case is when a constant quantity is subtracted from each term. So I'll mention that by subtracting a constant quantity. Once again, I'll consider the sequence. Let sequence be a plus d, a plus 2d, and so on. Suppose a constant quantity k is subtracted from each term. A new sequence is formed. It will be a minus k, a plus d minus k, a plus 2d minus k, and so on. Here, first term is a minus k. Common difference is second term minus the first term. We get a plus d minus k minus a plus k. Here they get cancelled. We get d as the difference. Suppose if you take third term minus the second term, it becomes a plus 2d minus k minus a minus d plus k. K gets cancelled, a gets cancelled, 2d minus d. Again we get it as d. Since common difference is same, we can conclude that a minus k, a plus d minus k, a plus 2d minus k, and so on is an AP. Therefore, whenever a constant quantity is added to or subtracted from each term of the arithmetic progression, then the resulting terms of the sequence are also in AP with the same common difference. Next property. If each term of an arithmetic progression is multiplied or divided by a non-zero constant quantity, then the resulting sequence forms an arithmetic progression. Once again, I'll make this into two cases. In the first case, I would like to consider multiplication of a constant quantity. In the next case, I'll consider division by a non-zero constant quantity. So let me write the case 1. Case 1 is on multiplying a constant quantity. Let the arithmetic progression be a plus d, a plus 2d, and so on. Suppose a non-zero constant quantity k is multiplied. The new sequence formed will be ak plus dk, ak plus 2dk, and so on. Here, first term is ak, common difference is the second term minus the first term, ak plus dk minus ak. We will be getting d times of k. Suppose if I consider third term minus the second term, what will be the common difference? Third term is ak plus 2dk minus of the second term is ak plus dk. On simplification, we get it as ak plus 2dk minus ak minus dk. This a times of k get cancelled. 2 times of dk minus dk will be dk. Since common difference is same, this implies ak plus dk, ak plus 2dk, so on, is an AP. So whenever a constant quantity is multiplied to each term of an arithmetic progression, the new sequence formed also results in arithmetic progression. Let us continue the same thing for the next case, that is dividing by a constant quantity. Let me consider arithmetic progression be a plus d, a plus 2d, and so on. Suppose non-zero constant quantity k is divided from each term, then the new sequence formed will be a by k plus d by k. This is second term. The third term is a by k plus 2d by k, and so on. Here first term is a by k, common difference is second term minus the first term, a by k plus d by k minus a by k. A by k will get cancelled. We get the common difference as d by k. Do we get the same common difference if you consider the next two terms of the sequence? Suppose if I consider the third term is a by k plus 2d by k minus the second term a by k plus d by k, what will be the difference? This is a by k plus 2d by k minus a by k minus d by k. A by k get cancels. We get the difference as d by k. Since common difference is same, we can conclude that the new sequence a by k plus d by k, a by k plus 2d by k, and so on, is an arithmetic progression. So when each term of an arithmetic progression is multiplied or divided by a non-zero constant quantity, the resulting sequence also forms an arithmetic progression. Next property, in an arithmetic progression of finite numbers of terms, the sum of any two terms equidistant from the beginning and the end is equal to the sum of first and last terms. It is little complicated to understand. In an arithmetic progression of finite numbers, sum of any two terms equidistant from the beginning and at the end is equal to the sum of first and the last terms. Let me consider a to be the first term, d to be the common difference L to be the last term and n be number of terms. In this case, this n value is a finite because they have given it's a finite number of terms. What will be the second term? From the end, second term from end will be the last term minus the common difference. What will be the third term from the end? It will be L minus 2D because common difference has to be subtracted from the second term. So D is subtracted from L minus D. It results in L minus 2D. Fourth term from the end is L minus 3D. Similarly, if you continue this process at some point of time, let me consider the rth term from the end will be L minus R minus 1 into D. We have learned nth term of an arithmetic progression. We have used the formula A plus n minus 1 into D. This nth term will be from the beginning. If I apply that logic, the rth term from the beginning will be A plus R minus 1 time of D. So now let us take the sum of these two. Sum will be L minus of R minus 1 time of D plus A plus R minus 1 time of D. Let me simplify. It will be L minus R multiplied to D, RD plus D plus A plus RD minus D. Here D get cancels, RD also get cancels. We will be getting A plus L. So look at this, A is the first term, L is the last term. When they are added, sum of any two terms equidistant from beginning and the end is equal to sum of the first and last term. This is sum of first and last term. Sum of first and last term. This is the property. This is only for your understanding. This type of properties may not be asked. Last property for today's session. Three numbers x, y and z are in arithmetic progression if and only if 2y is equal to x plus z. Let me assume that these numbers are in arithmetic progression x, y and z. X, y and z are in arithmetic progression. What will be the common difference? Common difference will be either y minus x or it is z minus x. Since the common difference is same, I can equate that. If you transpose It is not z minus x, sorry, this is z minus y. If you transpose y to the other side, it becomes y plus y is equal to z plus x. So 2y will become equal to z plus x. Not only this, the converse is also true. Conversely, let x, y and z are three numbers such that if 2y is equal to x plus z, then we can say that x, y and z are in arithmetic progression. These concepts are very important because in some of the competitive examination, when this format is there, 2y is equal to x plus z, we can say that the given numbers are in arithmetic progression. That's all for today's session. Thank you.